Okay, this is the first of a little series of videos about the number patterns question that has been a bit of a banker in the exam over recent years. So I'm going to start with a number pattern that I've just called P for pattern. So the first term in the sequence is 5, the second term in the sequence is 7, the third one is 9, and so on. So the n numbers are just the number of the position in the sequence, 1, 2, 3, 4, 5, 6, 7, 8, so on. And the p numbers are the numbers in the pattern that we've got to try and establish some kind of a rule for. So it says, first question, write down in words any patterns that you might observe. Well, you might observe that they go up by 2 every time. Plus 2, plus 2, plus 2, and so on. So write down in words any patterns that you observe. You might write then the numbers increase by 2 every time. You might also observe that the numbers are all odd numbers. 5, 7, 9, 11, they're always going to be odd numbers. So that's the first bit of the question. And when you see the command term write down like that in words, then that's exactly what they want. So you're not trying to achieve any kind of algebraic rule, anything with any kind of symbolism. That's out the window. This has got to be a plain English description. Okay, it says predict the next 4 terms in the sequence. So it's going 5, 7, 9, 11, plus 2 every time. So 13, 15, 17, 19, C table. That's that one done. That's probably the easiest and quickest marks you'll get. Okay, find a general rule connecting P and N. So this is where the big money for the marks is. I'm just going to get rid of that. So we have observed that P goes up by 2 every time. So every time the number in the sequence goes up by 1, the actual term we're looking for is going up by 2 every time. Now that is an example of an oopsie. That is an example of an arithmetic, if I can get this pen to write that word, an arithmetic sequence. So something where there's a fixed difference between each term from one term to the next, that's called an arithmetic sequence. And the fact that these go up by 2 every time, that these go up by just 1, give you a clue that there's got to be a 2n sometimes in the rule, because the numbers we're trying to get are going up twice as fast as the n numbers are going. So if our rule was just 2n, 2 times n, the first one would be 2 times 1, which is 2. The next one would be 2 times 2, which is 4. Then you'd get 6 and 8 and 10 and 12 and 14 and 16. So we are getting a sequence that's going up by 2 every time, but it's not the sequence we want, because where we want 5, we're only getting 2. Where we want 7, we're only getting 4. So we need to take the numbers we are currently getting and add 3 to each of them. And then we'll get 2 plus 3 is 5, 4 plus 3 is 7, 6 plus 3 is 9, 11, 13, 15, 17, 19. And now we've got a pattern that matches the ones we're trying to get. So the rule is 2n plus 3. So we need to write that down as an equation, P is equal to 2n plus 3. Okay, now we have the bit that says test and verify your rule. Now you're going to do very similar things for that in the exam, but you just need to know what those things mean. So I'm just going to get rid of some of the other stuff I did. Boom. Delete. There we go. Get rid of that one there and that one there. So when they ask you to test your rule, what they want you to do is to take something where you already know both values and check that your rule still works. So I'm going to do it a couple of times. I'm going to do it for 3 and for 4. So I'm going to say when n equals 3, my rule says P equals 2n plus 3, which is 2 times 3 plus 3, because n is 3. 2 times 3 is 6, plus another 3 makes 9. So when n equals 3, according to my rule, P should be 9. And if we look at the table, P is 9 when n equals 3. And we need to make that observation in the exam. So this matches the value in the table. And there's often a mark just for writing that bit at the end that compares the value that you got and checks that it matches the value in the table. Okay, so in an exam situation, I might do that a couple of times. So I might do it when n equals 3, and then I might do exactly the same when n equals 4. So when n equals 4, then my rule says that it's going to be 2 times 4 plus 3, which is going to be, let's just fill all those things in. When n equals 4, my rule says P equals 2n plus 3, which will be 2 times 4 plus 3, which will be 11. And back to the table, that matches the value in the table. So when they say test your rule, they want you to do that for something where they've given you both the position in the sequence and the actual value of the sequence. Now, let me just delete that lot, tidy up a bit. When they ask you to verify your rule, it's exactly the same thing, but you are doing it for the part of the sequence where you predicted some of the values. So I might, for example, do it for 7 and for 8. So when n equals 7, delete, and delete the 7, and delete that. So when n equals 7, my rule says P equals 2n plus 3, which will be 2 times 7 plus 3, which will be 17. And that matches the prediction I made by just adding 2 every time. So I'm just going to write this matches the value in the table, or I could write this matches my prediction in the table. This matches, going all over the place with this pen now. Delete. This matches my prediction in the table. That almost says table. Okay, but you know, there's always these kind of 3 bits to it. So a clear heading, when n equals some value that you're testing or verifying, my rule says this, and work out what that is, and then the observation, this matches my prediction in the table. And there is often a mark for that last bit just by making the statement that you've compared what you've got from your rule with what's in the table. So I'm going to do it one more time for n equals 8. So I'll just change that for that. So when n equals 8, my rule says p equals 2n plus 3, which is going to be 2 times 8 plus 3, which is going to be 16 plus 3 is 19, and 19 is indeed in my table. So this matches my prediction in the table. So typically in an exam situation, I might do a couple for test, a couple for verify. If I couldn't remember which one was test and which one was verify, I might just do one whole section that says test and verify, and then just do a couple of low ones and a couple of high ones. But once you get into the swing of that, it can be very easy marks. And of course, in the exam, you can cut and paste things, just like I've been cut pasting there, and save yourself a lot of time picking up a lot of marks for something that's actually quite repetitive. Okay, so example 2. So these are going not up, but down by a fixed amount every time. So the fact that it's going down by a fixed amount every time tells you that it's still an arithmetic sequence. So write down in patterns any numbers that any patterns. Write down in words any patterns that you observe. So the numbers go down by 5 every time. So again, something in words, a sentence in English, not a statement involving algebra. They've clearly said write down in words. You might write the numbers are all multiples of 5 in this case. Predict the next 4 terms in the sequence. Okay, so that's easy to do. Just keep going down by 5 every time. So you don't need to have figured out the rule to have done this. So predict the next 4 terms in the sequence, see table. Okay, so here's the killer. Find a general rule connecting P and N. Okay, well, the fact that the P's are going down by 5 every time the N's go up by 1 gives you the big clue that there's a minus 5 times n in the rule. So if the rule was minus 5 times n, you'd have minus 5 times 1, which is minus 5, minus 5 times 2, which is minus 10, minus 5 times 3, which is minus 15, and so on, minus 20, minus 25, and so on. So we are getting something that's going down by 5 every time, but we're getting these numbers and we want these numbers. So we need to add 105 to each of these numbers to get these numbers. So minus 5n plus 105 will get us the ones we want. 100, 95, 90, 85, and so on. So the general rule is P equals minus 5n plus 105. And again, you need to write that as an equation. Something is equal to something else. Okay, so test and verify your rule is again the same thing. So when n equals, let's do it for 3 and 4. When n equals 3, my rule says P equals minus 5n plus 105 equals minus 5 times 3 plus 105 equals minus 15 plus 105 equals 90. And if I look at the table, when n equals 3, we do get 90. So this matches the value in the table. So I'll do one for n equals 3. I'll do another one for n equals 4. Just get rid of the 3's and the bits that follow on from them. So again, very easy to do this kind of cut and paste in the exam interface as well. So when n equals 4, my rule says p equals minus 5n plus 105, which is minus 5 times 4 plus 105, which is minus 20 plus 105, which would be 85. And this value matches the value in the table. So that's my testing, doing it for the values that were already there. And then I'm going to try and verify it with a couple of the higher values, let's say 6 and 7. So when n equals 6, I'll just change all these 4's to 6's and then everything else that follows on from them. When n equals 6, my rule says p equals minus 5n plus 105, which is minus 5 times 6 plus 105, which is minus 30 plus 105, which is 75. And it matches the value in the table, 75. So again, a potential mark for that comment at the end. I'll do one more. When n equals 7, delete that, delete those, delete. When n equals 7, my rule says p equals minus 5n plus 105, which is minus 5 times 7 plus 105, which is minus 35 plus 105, which is 70. This matches the value I got in the table. So if you can get that down to speed, it tends to be a very large chunk of the marks most years. So just the whole routine of recognizing the key terms and then write down, predict, find a general rule, test your rule, verify your rule. If you can get up to speed with what they're asking you to do in that question, then you can knock it out of the park pretty quickly. Okay, so those two were arithmetic sequences, and part 2 of the video will concern geometric sequences. We'll see what that is in part 2.